Hello, welcome everyone. This video was made based on the request of Professor Mokhtar al-Ghurafi. With you is the student Huda Abdulaziz al-Ulfi, a pharmacy student in Sana'a University. The most important reason for making this video is the knowledge of the synthesis and formation of chemicals and medicines. So, how we will know that? The answer to this question will be through the use of spectrophotometers. First, we must know what spectrophotometer means. It's an instrument used to measure the transmission of light at different position length of symbol. So through spectrophotometer, the symbol is measured, analyzed, and its shape and composition are known. There are four types of spectrophotometer. Well, here I will give a simplified explanation for each device, starting with ultraviolet visible device, and its function is to determine the correlation with pi bond and if there is resonance or not. Then I move on to the mass ray device. Its main function is to know the molecular weight of the symbol. After that I move on to infrared device, and its function is to know the functional group of compound. This device creates a graph between the number 600 and 4000. Each functional group appears in a specific number. The last device is NMR device that works to know the number of carbon and hydrogen atoms and their arrangement. Now we will work to apply what was explained in detail. Question number 2. Starting with IR spectrometer. From IR we notice that 1. There is absorption of broad peak between 3500 and 2500. This indicates the presence of stretching of OH group. 2. There is sharp absorption at 1715. This indicates the presence of stretching carbonyl group. It may be carboxylic acid. Presence of both OH, C double bond O may indicate the presence of carboxylic acid. However, to ensure how many double bonds, we use the low index of hydrogen deficiency, which is Cn H2n plus 2 minus H divided by 2. To determine the number of double bonds that present in the compound by using C3H6O2. So, after doing the calculation, the result is 1. So we have one double bond that indicates the presence of carbonyl group. It may be carboxylic acid. Now with the second spectrometer, which is NMR, starting with HNMR, which is responsible for determining H atoms. So here we notice that there are two environments. First, we have a triple peak between 1 and 1.5, indicates that is neighbor to CH2. Second, we have quarter peak between 2.3 and 2.5, indicates that neighbor to CH3, exchangeable with D2O2OH. Then C13, which is responsible for determining carbon atoms. We notice that from depth 1, presence of the peak upward indicates the presence of CH or CH3. 2. Presence of the peak downward indicates the presence of CH2. There are two aliphatic carbon environments between 0 and 30, and one peak between 170 and 180 that ensure the presence of carbonyl group. Now, moving to mass spectrometer, we notice the following. 1. The fragmentation pattern in the mass spectrometer showing up the molecular weight 74 indicates the presence of molecular ion peak. 2. At peak 74 indicates to remove fragment has molecular weight 29 is carboxylic group. After all spectroscopic information, we found the result of the structure is propionic acid.